but squared. So the f-test and the t-test are exactly the same test, except you square the t-statistic to compute the f-value. Using SPSS, to perform analysis of variance. Here I have the data in an Excel file. We have weight gain, we have the 6 diets, we have some other information defining the diets, the source of protein and the level of protein. So each variable is in a column. First column is weight gain, next is diet, and then I've also got the other ones defining the diet, source of protein and level of protein. After starting up SPSS, you open up the Excel file. It's in the file diet. The variable names are, if they're in the column, that should be checked. If you want to read just a special range of the Excel file, you'd put that in. If you don't put anything in, it reads the whole data. So it's read 4 variables in: weight gain, diet, source, and level. Go back to the Excel file. The first row had the variable names in, and then afterwards it had the measurements. So there's the SPSS data file. Looks very similar to the Excel file. So to perform analysis of variance, you go to Analyze, General Linear Model, and select Univariate. Up comes this box. Here you now have to introduce the dependent variable, that's weight gain. And you have to put in the fixed factor. There's really only one factor here, it's diet. This program can be used to analyze really much more complicated experiments with many factors. Once you click that, you press OK, and it performs the analysis. There's the ANOVA table that comes out. That's part of the output. That was similar. I'll go back here. To this one, which I did by hand. This is the sum of squares for comparing the 6 diets, 5 degrees of freedom for comparing the diets. This is for estimating error within the samples. There's 9 degrees of freedom within each sample of 10. For estimating error, those can be combined to make up the 54 degrees of freedom here. There's the F value, and there the significance is the P value. This allows you to avoid having to look up the table. This is telling you that if you looked up the table for 0.05 or 0.01, this is going to be inside the critical region. Some comments. The F-test is testing whether the means are all equal against the alternative, at least one pair is different. If H0 is accepted, then you know that all the means are equal, not significantly different. If H0 is rejected, we can conclude at least one pair of means is significantly different. The F-test doesn't tell you which pairs. Now what you can do is perform 2-sample t-tests to see which pairs are different. This is called Fisher's LSD procedure. LSD is not the drug, means least significant difference. So to perform Fisher's LSD test, you first test whether the means are all equal against the alternative that at least one pair is different. If H naught is accepted, you know that the means are all equal and you stop there. If H naught is rejected, then in Fisher's LSD procedure, we use two sample t-tests to determine which pairs are different. Here's an example. This is the diet example. There's the 6 diets. There's the mean, standard deviations, sums. These two sums, sum of x and sum of x squared, are used to calculate the ANOVA table. There's calculation of the ANOVA table. The ANOVA table finds that there is a significant difference amongst the 6 means. Then we would go on and perform 2 sample t-tests. This is how you'd compute the value of t. You'd select for which pair of means you subtract. S pooled is the square root of the mean square within. The degrees of freedom associated with that is 54. The critical value for 54 degrees of freedom for a t-value is 2.005. So anything greater than 2.005 is significantly different. There are the means. There are the difference in the means. And this is actually the t-value. Critical value is 2.005 for 54 degrees of freedom. So everything that's greater than that is significantly different. So you see that diet 1 is significant than diet 2, not significantly different than diet 3, significantly different than 4, 5, and 6. These are the 3 low protein diets. Diet 2 is significantly different than diet 3. It's also different than diet 1. 3 is significantly different from the 3 low protein diets. Then there's no difference between 4 and 5. Uh, 4 and 6, 5 and 6. So there's no difference amongst these 3 diets here, the 3 low protein diets, and the low protein diet is not significant from the high protein cereal diet. It is significantly different from the high protein beef diet and pork diet. So what one can conclude is that increasing the level of protein increases weight gain, but only if the source of protein is a meat source, beef or pork. So high protein diets result in a higher weight gain, but only if the source of protein is a meat source. You can see this with box plots. There's the box plots. The high protein meat diets are higher than the low protein diets and the high protein cereal diet. There's no difference amongst the high protein cereal and the together with the low protein beef diets. Now, I think I'm not going to go any further today, but I was going to do this in the lab, but maybe we'll cancel the lab and do this now to analyze, show you how to analyze question 3. Okay, so this is the data from question 3 right here. Question 3 had cancer patients being treated with radiation. The first group of patients had been given no radiation. The next group of patients had been given 25 to 50 roentgens of radiation. And then the next group was a higher dosage, 75 to 100 roentgens, 10 patients there. The last group had a radiation of 125 to 250 roentgens. The subjects were measured. Were given an intelligence test score before treatment and then after treatment. So the question is, how does the radiation treatment affect their scores on the intelligence test? So I'll just shut this down and I'll open up SPSS. Let me just close this. I'll be putting up okay, so I'll start up SPSS. No. I'm starting up the wrong one. Yeah, I'm starting up the wrong one. It's version 25, which I don't have a license for. This is the one I want to start up, 27, which I do have a license for. Okay, I want to open up another file. It's an Excel file. It's on my desktop, and it's the one that was downloaded. Assignment 3, computer data. Open. There's a pretest score and a post-test score and treatment. Now, I'll press OK. And there is the data. Now, this is different than the file that you will access because I put a 0 in front of the control treatment, a 1 in front of the lower dosage, because then when I do graphs, it'll put them in the correct order. Now, I'm not interested in the pretest score or the post-test score. I'm actually interested in the drop. So to do that, I'll do a transform computer variable. This will be the drop. And it will be the pretest score minus the post-test score. Press OK. And that will have computed that. If I go into window, the data set, it's computed this minus this. One way of looking at this is to look at a graph.
You've had the ball. You've had the ball.
Look at a graph.
Fuck, okay.
Okay, and I'll use it with a box plot. This. Along here, I'll have the treatment, which is the radiation treatment. And here I'll have the drop in the score. Press OK. And then we get a rough graphical picture. Here's the radiation treatments. The control are people who didn't receive any radiation. And you can see that as you increase the radiation, you're increasing the drop on those two scores. So to do the testing, I'll go Analyze, General Linear Model, and I'll put out a PowerPoint presentation which will go through this. It's univariate. The dependent variable is drop. The fixed factor is treatments. Press OK, and it will carry out the ANOVA F test. Here's the ANOVA F test. This is the sum of squares comparing the 4 treatments, 3 degrees of freedom there. This is the sum of squares estimating the within subject variability. The F test is here, 36.06. This is the p-value. When that p-value is small, there is a significant difference amongst the 4 treatments. Now, if you wanted to perform Fisher's LSD test, I'll go back to here, general linear model, univariate. So I've got everything in here. If you click on post-hoc, it'll tell you the post-hoc text. This is for comparing the 4 treatments. And LSD, it will then perform the LSD procedure on the 4 treatments. Press OK. And here is the LSD procedure here on the 4 treatments. The ones that are greater than 0.05 or 0.01, the significance are ones that there's no significant difference. So this tells you that the control treatment is no different. There's no difference between that and the low dose of radiation. There is a difference with the higher dose of radiation. The low dose of radiation is not different than the control treatment, but is different than the higher doses of radiation. Then the medium dose of radiation is significantly different from the other three groups. The high dose of radiation is significantly different than the other three groups. So what we learn from this is that if you treat the patients with the lowest dose of radiation, 25 to 50 Roentgens, there won't be a significant drop in the intelligence scores. There will be a significant drop with the two medium dose of radiation and the high dose of radiation. So again, I think I'll cancel the web lecture this afternoon, and I'll post a PowerPoint presentation going through the steps that I've just gone through. Okay, so at this point, we'll end the lectures, and if you have any questions, we can ask them now. Okay, so at that point, I'll end the.
Professor,
Yes.
so for this computer assignment, the stuff that we have to include on what we submit would be the graph and then all the different tables you created, correct?
Yeah. There'd be the graph. Then there's the ANOVA table, which is asking the question, are there any difference in the 4 treatments, the control treatment and the 3 drug treatment and the 3 radiation treatments? And then there's the LSD procedure, which tries to find out which treatments are different.
Okay, thank you.
When can we expect that?
Yeah. In practice, if you found no difference in the treatments from the F-test, you'd stop at that point. You wouldn't go on to do Fisher's LSD procedure.
When can we expect that PowerPoint to be posted?
It should be posted sometime this afternoon, or probably this evening, because I have to prepare it. Okay, so I'll send out an email to everybody saying that the lab lecture will be canceled this afternoon. I was planning to do the what I just did in that lecture, but I have enough time to do it in today's lecture. So at this point, we'll end the meeting.